Hello and welcome to today's lesson. Today we are starting chapter 7 and we are going to be doing angles of a polygon. Notice in here this is going to be one of the lessons today when we're talking about interior angles and exterior angles. So when you have a figure, if we extend one side, this is called the exterior angle and this is the interior. Okay, now if we extend it going this way, this is your exterior angle and this is your interior. So this one in here is not called an exterior angle. Remember, this one is vertical to the interior angle. All right, what are some properties of polygons? And some properties of polygons here, nothing's coming up. There it is. Okay, to be a polygon, it first must be a closed figure. It must be formed by 3 or more segments, and the segments only intersect at their endpoints. So something like this is not considered a polygon because this is the midpoint of this segment and they can only meet at endpoints. It has to be closed. So we cannot have this space in here. It has to be closed, and you cannot have it with fewer than 3 or more segments. Okay, and it has to be segments. So something like this is not considered a polygon because this part over here is not a segment. All right, so which one of these are polygons? Is this a polygon? Yes or no? Yes, this is a polygon. How about this? Polygon or no? No, because it's curved. Polygon or not? Yep. This, no, because again, it's curved. This one, no, because it's not closed. This one, yes. This one, no, because it's not at the end point. All right, what is the diagonal of a polygon? So a diagonal is a segment that joins 2 non-consecutive vertices. So if we connect B to C, that is not a diagonal because those are consecutive. But if you look at B and D, those are non-consecutive. So when we connect B to D, this is considered a diagonal. So now when we look at convex and concave polygons, if you draw a diagonal, so this point, here's the consecutive vertice, and this one would be non-consecutive. So when I draw this diagonal in, if any point of the polygon is now on the interior of that, then that is considered to be concave. So if any part of the diagonal contains points in the exterior of the polygon. All right, so these are both good because when we have non-consecutive, this is in the interior. Here, that point is in the interior of that, so it is concave. All right, what is regular versus irregular polygons? Well, regular polygons have equal angles and equal sides, so equilateral and equiangular. So it is not just the equilateral triangle. We have 3 sides, so that is equilateral, and it is equiangular. So if we go to the polygon, the 4-sided polygon, it is equiangular if they are all right angles, and if we have 4 congruent sides, and so that specifically is called a square. All right, now let's talk about number of sides. So some of you might want to copy this down, some of you might not, but just know that when we talk about the sides and I tell you a 3-sided figure, or I say, hey, we're talking about a triangle, then you need to know that. If I say quadrilateral, you need to know 4. And you guys probably know them all the way down. A 5-sided is pentagon. So I'll say, what are the interior measures of a hexagon? And you need to know that the hexagon is going to have 6 sides. Or when I say a nonagon, Okay, if we're talking about a nonagon and I would like to know the sum of the interior angles, you need to know that a nonagon has 9 sides. Okay, and a 9 and a 10, they do not. Notice how they skip 11 in here? There's no special name for an 11-sided polygon, but we do have a special name for a 12-sided, and that's called a dodecagon. So if we're going to talk about the 11-sided, we would just call it by name, and we would call it an 11gon. If a polygon had 16 sides, we would just call it a 16gon. But if we talk about a 12-sided figure and you call it a 12gon, you would get that marked wrong because a 12gon actually has a name, and it's called a dodecagon. All right, now talking about the sum of the interior angles. Well, we know if we have a triangle has one angle, and the sum of those is going to be 1 times 180, which is 180. You know the sum of the angles in a triangle are 180. Okay, so we got the quadrilateral over here on the side, and if we draw one diagonal down, what do we have? We have 2 separate triangles. So what is the sum of the interior angles of a quadrilateral? And you guys probably already know that that is 360. 2 times 180, what gives us 360. All right, so now if we go to the pentagon, and if we draw on this diagonal and this diagonal, we now have a 1, 2, 3 triangles. Okay, whoops, what's going on? So now we have 3 triangles. So what is the sum of all of these angles for a pentagon? And so you can see the pattern, 1 times 180, 2 times 180. This one's going to be 3 times 180. And then if we go down, it's going to be 4 times 180. Okay, so what is this general formula that we have here? Well, let's look at the number of triangles. 1, 2, 3. You know the next one's going to be 4. So what are we going to have? If we've got n over here, what is going to be underneath here in red for this number of sides? And if you look here, this is 3 to 1, 4 to 2, 5 to 2, 6 to 4. So what are we doing every time? Aren't we taking this number, and then how do we get to 1? We are subtracting 2. So this nonagon is going to be n minus 2. Okay? So now, what does that mean that we're going to do over here? Well, we were just taking this number, 1 times 180, 2 times 180, 3 times 180, 4 times 180. So what is this last column going to be? Well, it's going to be n minus 2 times 180. And this is the formula for finding the sum of the interior angles in a triangle. So the sum of the interior angles in a triangle is n minus 2 times 180. N minus 2 times 180. All right, calculate the sum of the interior angles in a regular heptagon. So heptagon is 7. So our formula is n minus 2 times 180. So we have 7 minus 2 times 180. So we're going to take 5 times 180, and I don't know what that is off the top of my head. So 5 times 180 is going to be 900 degrees. So the sum of the interior angles is 900 degrees. Now, what if they ask what is the measure of each angle? And because it's regular, we know each one is the same, and a heptagon is 7, so we can take 900 and divide by 7, and we are going to get, if we round it, it's going to be 128.6 degrees. All right, so that's finding the total sum of the interior angles, and then the 128 is each individual angle. All right, find the measure of each interior angle of a pentagon. Well, we're going to add up 18C plus 32C plus 32C plus 18C plus 35C. 1, 2, 3, 4, 5. Okay, 5 angles, together to be a pentagon. And so the pentagon, remember that formula, is n minus 2 times 180. So pentagon is 5 minus 2. So we're going to do 3 times 180, and 3 times 180, I think, is going to give us a 540. All right, so now we just add all of these up and find out what C is, and then we can plug them all in. All right, the sum of the interior angles of a regular polygon is 6,660. How many sides does it have? Well, usually we're taking n minus 2 times 180 to get the sum. Well, this time we have the sum, and we know that that sum is 6,660. So our first step in solving is going to be to divide both sides by 180. So now n minus 2, I think that comes out to be 37, and then we add 2. So the number of sides is going to be 39 sides. All right, we have one concept left to talk about, and that one concept is going to be to talk about exterior angles. So let's just say we have an equilateral triangle. So if these are each 60, okay, if we're going to extend that exterior angle, extend that exterior angle, and extend. Now I specifically picked this so we'd be able to do the math in our head. The measure of this angle is 120. The measure of this angle, because it's a linear pair, is 120. And this angle is 120. So what is the sum of the exterior angles? Sum of exterior angles is 360. Okay, so let's try now a square. Okay, so this is a square. So if we extend each side to get the exterior angle, we're going to have 90, 90, 90, and 90. What's the sum of the exterior angles? Well, 90 times 4 is 360. Now, do you think that's coincidence that happens just for your triangle and just for your square, or do you think that happens for all of them? And so what we find out if we were in the classroom is we would do those exterior angles, and we would find out that the sum of the exterior angles of a polygon is always 360 degrees. It doesn't matter if you have a pentagon or a hexagon, if it's regular, if it's not regular, if it's a dodecagon. The exterior angles will always add up to 360 degrees. So find the measure of each exterior angle of a regular 20gon. Okay, well, we know that the sum of all of them is 360. So if they're going to have 20 sides, we're just going to divide by 20. That cancels out, and they're going to be each exterior angle is going to be 18 degrees. And because it's regular, do we know what the interior angle is? Remember, the exterior forms a supplementary or a linear pair. So we can take 180 minus 18 and get that. So 180 minus 18. And so the interior angle, each interior angle would be 162 degrees. All right, find the measure of each exterior angle. So we've got 4 of them. So we're going to add them all up. 8r plus 4r plus 5r plus 7r. And that sum, because they're exterior, comes out to be 360. So you find out the measure of r and then plug it in. All righty. Good. Well, we have one assignment left here, and let's see if we can figure this out. The measure of each interior angle. So if the interior angle is 177.5, remember it makes a pair, linear pair, so we're going to take 180 minus 177.5. So that gives us 2.5 for each exterior angle because it's regular. So now if you take 360 and divide by 2.5, 360 divided by 2.5 is 144 sides. Phew, I finished. Good luck on your homework.